Hello everyone, and welcome to our 3D Systems webinar, Part Quality, Print Speed, and Simplicity Matter in 3D Printing. Today, our guest speaker, who many of you out there may have heard before on our previous webinars, is Derek Johnson, our Director of MJP Product Management. And we're excited to also be able to take your questions today at the end of the presentation. We will answer questions live, and any questions that we don't get to, we will also answer via email. And just before we get started, we also will be covering our end-to-end digital workflow. Digitize, design, simulate, manufacture, inspect, and manage. You'll learn how 3D Systems is a full-service provider. And without further ado, I'd like to welcome Derek Johnson.
Good morning, good afternoon, good evening to everyone. Again, my name is Derek Johnson. I'm the Director of MJP Product Management here at 3D Systems. I've been with the company about 11 years. I'm very excited and proud to have seen the technology grow and evolve over the years. I can say that I've been a part of the 3D printing industry for 1/3 of its existence, and it's been a very exciting ride. So I'm extremely humbled and proud to be able to share a little bit more of what we are developing and many of the great advancements that we have made over these past many years. As Dennis mentioned, as the leader in rapid manufacturing and pretty much end-to-end solutions, we're really excited to show you and talk to you about how we can really create products that help your ideas matter. The ideas, the new designs, the new products that you are developing today, we are hard at work developing new solutions to make that job a lot easier. Today, we're gonna focus on the multi-jet printing technology. I'm gonna talk a little bit more about what that means and what it is. And specifically, within the MJP family, we're going to talk about the ProJet 2500 3D printer. And we're going to focus on some really key advantages within that printer family: part quality, speed, and simplicity. And it really allows those that are looking to get into 3D printer, gives them that accessibility even easier than before. So let's talk a little bit about ProJet MJP 2500 and different ways that people are using that printer today. The printer is designed to create precise plastic and elastomeric models and prototypes, primarily for concept models, whether it's an industrial engineer doing rapid design iteration or creating communication and sales tools, models for visual inspection and verification, or architecture, engineering, and construction models. The printer is also being used for functional prototyping, design verification, and testing. And I'll give you an example. There's a customer who, during a customer visit, I was able to see what they were using their printer for, and they are creating camera housings. And they were able to create a very precise camera housing and do underwater testing using the ProJet 2500. They were able to print out a main body as well as several accessory parts that they were able to bolt together with glass and submerge in water over a weekend. So this allowed them to test the design for water fastness. This allowed them to get feedback very, very quickly and very, very efficiently. Other types of applications and things that people are doing, of course, assembly testing, like I just described, mechanical, functional testing, fluid flow analysis. Because the ProJet 2500 can run elastomeric materials, that opens up other applications that require an elastomeric material, as well as educational prototyping in various educational and training institutions. So, like I mentioned, we're going to focus on 3 key advantages with the ProJet MJP 2500, and that's part quality, speed, and ease of use. And I'll go into more detail into each and talk to you about why those matter and why those are important. Wanted to start by sharing a few words and testimonials that we have from customers that have experience with the ProJet MJP 2500. This is a quote from one of the prototyping managers at Nike, who has had extensive experience with the ProJet 2500. And you can read the quote. They've been impressed with the results. It complements their current technologies and allows them to do a lot of different complex geometries that they were not able to do on other printers. Now, a little bit of information about this particular department. This department receives prototyping requests from various functions within the company. So they're the model shop, and they have a number of different technologies that they run, from our 2500 all the way up to high-end SLS printers. So during their time using this printer, the other departments actually started to request parts off of this printer because they had become accustomed to the part quality, to the performance of the materials, and they liked it so much that when they placed orders for new models, they were actually requesting models off of this printer. So it's just another testament of the versatility and the various application roles that this particular printer can fill. Another application example is with a company called Crescent in Japan. And as you see in the photos, they actually use a 2500 to create a functional mock-up of a virtual reality headset. And so this prototype allowed them to reduce the weight by 1/3 compared to the old version. So again, the ability to create an accurate part that is functional and allows engineers and designers to very quickly test and verify gives them a large range of improvements in terms of product development. And another recent application success story is with AEG International in partnership with one of our authorized partners, Duncan Parnell. The new product is called the Firefly, and it's a solar-powered bank of LED lights. And as you can imagine, this is extremely important in regions of the world that do not have very extensive electricity grids. And so with this being a mobile device and being a solar device, it's extremely green and eco-friendly and does not require gases or expensive fuels. Now, AEG was able to use their ProJet 2500 to prototype the case for the new Firefly. And they chose the 2500 because of the accuracy, the part quality. They were using our clear material, so being able to have strong, clear parts, very easy to use with the melt-away wax supports, and we'll talk more about that in a little bit. The platform size was actually large enough to allow them to create full cases that they could then assemble and test. And then the print speed that allowed them to very quickly iterate and get several models out for quick verification. And so just another quote at the bottom, the ProJet MJP 2500 works very well and meets our goals, provides design flexibility and high quality parts that save time and cost. And that was from Scott Drayton, the VP of Engineering. So we're really excited about just a few of the success stories that we've received back from the field concerning the ProJet 2500. So now we're going to talk a little bit more specifically about why those 3 key elements we mentioned are so important versus similar technologies. So there are other inkjet printing technologies, and we want to talk in detail about how the ProJet MJP 2500 matches up against those technologies. So first we're going to talk about part quality and true to CAD accuracy. To start, I want to explain the technology differences. A lot of people have a misconception that all inkjet printing is the same. So I want to very briefly describe the difference between the print process for MJP and some other technologies. So with MJP, we are actually printing with a phase change material. Phase change basically means it can go from a liquid to a solid by heating and cooling. And why that's important is because every time we jet a droplet of material, we have control over that material. When it jets, the phase change support material allows a stability for the part material until we can actually UV cure that layer. Other technologies utilize a non-phase change material, which means it's liquid at room temperature, it's liquid when you jet it. And so if you can imagine pancake batter and how it spreads until it cooks enough to stop spreading, that's what happens with other inkjet technologies that use non-phase change material. Now that's a very technical explanation, but the next slide shows you what that means in terms of part quality. So if you look at this very simple part of a threaded screw, you can see a very stark difference between the MJP 2500 part and the competitive part. Sharp, accurate threads, which are very important when you are assembling a part that needs a thread, or you're assembling a part that needs to fit into a groove or fit into another space. Those kind of details really matter. Here's another example of ProJet 2500 part versus a competitive part. And if you look at those top two features, the detail and the sharpness is drastically different. And that's very important. Every detail on a part that an engineer designs is important. It's not arbitrary, but it's meant for a purpose. And so as an engineer, if you're designing something, you expect for your 3D printer to be able to keep up with the sophistication and the precision of your design. Here's another practical example, because a lot of times other technologies and other printers, their position is that, well, it's good enough. You know, the part quality is good enough. So I want to share an example about how good enough can actually cost you. So if you look at the bottom left, there's a typical shower head, and inside that shower head are various nozzles and jets. And those nozzles and jets are meant to create certain spray patterns. So we modeled a CAD model of the middle pattern on that shower head, and we printed the parts out on the 2500, printed them out on a competitive printer. And the results in the upper right-hand corner images are pretty significant. So the spray pattern that is expected is not what is provided by the competitive printer. And if you look at the detail of the actual nozzle openings, they're designed to be very small triangles. But on the competitive technology, those edges and those points are rounded out. That is what's affecting the spray pattern. The spray pattern is actually not fully open and allowing the water to come out. So that's why it's so important that the details and the precision of how a printer can resolve a CAD model is so important. And here's just another visual example of how high part quality can deliver results that you can trust. In the example on the left, that is a fully functional bearing with ball bearings on the inside. On the left, that ball bearing is completely frozen and not fully functional. And so again, based on the design, you want your design to perform as you designed it and as you intended it. And the ProJet 2500 is able to deliver that. Here's another example, just looking at small detail features. From the magnified images, you can very clearly see the 6 sides of the hexagonal pattern that's created on the inside of that part. On the competitive part, it looks more like irregular circles, some of those not being completely resolved through and through. So again, it's important that when you're designing parts, you have a printer that's able to support your design. Now we're going to talk about the second key advantage, which is speed. And ultimately, it's designed to part faster and easier. So in this example, we took the same build and we printed both builds on the two different printers. And you can see the difference in print time. This is total print time from beginning to end. The playback speed was accelerated, but you can see that a 12-hour print time versus a 36-hour print time. And that's really important because if I need those parts on a manager's desk within 24 hours, I'm able to start that print at 8 a.m. and walk in the next day and be ready to start cleaning. Whereas on the competitive printer, I've got a full 24 hours plus some just to finish the print. So being able to print lots of parts as quickly as possible allows engineers and designers to get their designs into their hands, iterate faster, and design and develop products faster and more efficiently. So speed is not only just about print time, but it's about all the other processes that are involved when going from a design to a finished part. And so from file to finish, we're very competitive as it relates to having those parts in your hand. So when you look at this graph, the total printing time plus the post-processing time is significantly shorter using the ProJet 2500. And in a minute, I'll talk a little bit more about post-processing. But again, this allows engineers and designers to iterate and evaluate, make changes, and continue that process a lot faster using the ProJet 2500. So the third key advantage that we're going to talk about is ease of use and post-processing. And so everyone who's running 3D printers wants to work less, but also get the best results possible. So this year we launched the MJP Easy Clean system along with the 2500, and this system is a very simple steam-based wax removal system. It is extremely easy to set up and use, very minimal handling of parts, and extremely fast for batch cleaning. And batch cleaning is really important because most people are printing multiple geometries. They have a number of parts that they're going to need to clean, and they want to be able to get through that process as quickly as possible. The MJP Easy Clean system allows you to put all of the parts on your build into the cleaning system and move it from step to step in one batch. And so from 0 to finished parts, you're able to have all those parts ready to go within a short amount of time. In contrast, our competitive technologies use a water dispersible support, which requires mechanical action. Now, the mechanical action of the water is extremely high pressure and can potentially damage very delicate parts. This is a rigorous process of holding a high pressure wand in one hand, holding your part in the other hand, and blasting all of the support off the part. It's time consuming. It's impossible to do batch processing. You pretty much have to handle each part one by one. And then there's a process of going back over the part to make sure that you were able to remove all of the support completely. So this is a very laborious, iterative process just for post-processing and getting to a usable part. Here's another example of why post-processing matters. So the part on the left shows a fully clean part that went through our MJP Easy Clean system. This particular geometry, as you can see, has internal features, and it needs to be completely clear of all support material. The part on the right had to go through a chemical soak. And a lot of times that chemical soak will create swelling that could actually damage or completely destroy the part, and render it useless. And so, again, post-processing matters. Think about or imagine all of the different geometries that you could design for your particular product. You don't want to be limited by the post-processing method of the 3D printer. You want to have complete design freedom and be able to design parts that are intricate, that have internal details, and to be confident that you're going to be able to get all of the support material out and still have a high-quality part to use for prototyping. So let's talk a little bit about some of the product specs for the ProJet 2500. We offer two models of the 2500, the 2500 standard model and the 2500 plus. They both have the same build envelope capacity, but they differ in the materials that you can run. So the MJP 2500 runs two of our rigid materials, the rigid white and the rigid black. The 2500 Plus runs all 5 of our materials, which includes 3 rigid materials as well as 2 elastomeric materials. Both models use our very eco-friendly support wax, and both models have a resolution of 800 by 900 by 790 dpi with a 32 micron layer thickness. So a little bit more detail about our plastics. We have 3 rigid plastic materials. We have a rigid black, rigid clear, and a rigid white. And they're all useful for different reasons and for different applications. Applications that are looking for something that looks like injection molded plastic, like cases and housing, the rigid black works really, really well. The rigid black is also the most balanced in terms of mechanical properties, with a moderate tensile strength and elongation profile. The rigid clear is a high transparency plastic. It is fully sandable, polishable. You can polish it, sand it, clear coat it for very high clarity results. The rigid white is kind of our blank canvas and is actually one of our most popular materials. It's got a really high white finish, extremely smooth surface finishes that can be produced, and it has really high tensile strength. So from a mechanical standpoint, these materials perform very, very well in a number of different applications as it relates to concept modeling and prototyping and functional testing. We have 2 elastomeric materials. We have ProJet M2, the elastomeric natural, as well as the elastomeric black. Both are very flexible. The elastomeric natural works really well in medical modeling. We have some customers that are creating prototypes of human anatomy and report that the softness and flexibility of the material allow them to simulate human anatomy. So it's a great application for that particular material. The elastomeric black is used for multiple applications where people need a soft elastomeric material, such as gaskets, bumpers, and other applications. The 2500 ships with 3D Sprint client software, which is one of our most powerful, easy-to-use client software. This software allows the user to very quickly upload their file. Multiple file formats are accepted. They can upload their file. They can check and repair their file. They can do moderate CAD work within 3D Sprint to get their file ready for printing. The software provides build time and material estimations. You're able to switch from printer to printer, and so it's very feature rich, and it ultimately allows the user to get in and out and submit their build to printing very quickly. So guys, in summary, again, we're really excited about the ProJet 2500 and making your ideas matter. It is definitely a strong contender in the market with providing exceptional part quality, blazing speed, and simplicity, not only in operating the printer, but also in removing supports, setting up builds, and overall function and operation of the printer. So that concludes our presentation. We are going to go ahead and open it for questions. So if you would give me a second, I'll go ahead and take a look at some of the questions that have come in so far.
Hi, everyone. If you would ask your questions in the Q&A section, we will get to them here now. However, due to time, we may answer some questions over email. So again, please ask your questions in the Q&A box on your screen.
So there was a question about use of the products in healthcare, and specifically they asked about I think they're asking about a stent for broken bones. Depending if this is out, these are the materials themselves are not qualified for medical use. Typically, we designate a medical use material as being Class 6 capable, which means that it is certified for contact with the human skin. Today, we do not have materials on the 2500 that are Class 6 capable. So for contact with this, long or short-term contact with the skin, this wouldn't be an ideal printer and application. We do have other MJP printers that are better suited for those type of medical applications. Someone asked a question about when we compare parts with the competitor technology, are we talking about another printer in the same price range? The answer is yes. We are talking about a printer that is in the same price range. And we didn't mention the price range for the ProJet 2500. The base model is $38,000 and the plus model is $45,000. And so the competitive technology is positioned right in that sub $50,000 range. There were a couple of questions about disposal of material. The material on all of the inkjet printing or any material that's UV curable has to be handled. Basically, all of us have special companies within our local regions that handle whether it's paints, alcohols, any kind of solvent. You would want to handle this material in the same manner by partnering with a company local to your region to come and dispose of that material. Now, that's for the part material only. For the support material, it's just a wax, and so that can be thrown in the trash just like regular waste. Someone asked about the difference in durometer between the elastomeric black and natural. Those have equivalent durometers, and the durometer is around a Shore A30. And so those are identical. And there is a question about the need to post-cure parts. These parts are fully cured inside the printer, so there is no secondary curing process required. So when you take the parts out of the printer, they're completely dry, completely cured, safe to handle. Someone asked if the MJP 2500 series is compatible with wood material. I think they might be referring to the material that we use in our Cube Pro Trio. The answer is no. Those are two different technologies and print processes. So this particular printer is fed with a liquid material that we then heat up and jet, whereas the ProJet or the CubeJet Trio is an extrusion-based technology that's actually using filament, a thermoplastic filament. So someone asked, are there any consumables? The consumables is the material. If you remember in the post-processing slide that showed a liquid, that's a soy-based oil that's used to remove all of the wax from the part. That's consumable that's purchased on a regular basis to aid in post-processing. There is a filter that typically is only replaced once or twice a year. That's it in terms of consumables. The primary consumable is the material that is used for printing, and that's the part material and the support material. Someone asked if you can print both the rigid and the flexible material in the same build. The answer is no. So this is a single material printer. You can run one of those 5 materials one at a time. We do have a multi-material printer, our ProJet 5500X, that does allow you to blend rigid plastics and elastomeric materials to create composites. But the ProJet 2500 is a single part material printer. Someone asked if the material on the 2500 could be used like our VisiJet M3X for injection molding. The mechanical performance that's required for that application is best suited for M3X. The materials that we offer on the 2500 are a little bit softer, and so they would not be ideal for injection molding processes. There are other rapid tooling processes that would be more compatible. Hydroforming, which is a low temperature but high pressure application where people can take flat pieces of metal and form them into shapes using a plastic mold. That would be an application where the 2500 and the materials would be a little more suitable. But for a serious injection molding application, I would recommend our ProJet MJP 3600 and the M3 material. So somebody asked, what does Sure A mean? So there are 2 primary scales that are used to describe the hardness of a material. Most plastics like ABS and polypropylene are on the Sure D scale. Anything that's softer like elastomerics and rubbers and polyurethanes are on a Sure A scale. And so each scale goes from, maybe 10 to 90. So when we say Sure A 30, that's a really, really soft elastomeric versus a Sure A 70, which will be a little bit stiffer, a little bit harder. So Sure A, Sure D basically describes the relative hardness of a material. So somebody asked if the Sure A value is fixed or if we're able to change the properties prior to the build. So today, the Sure A value is fixed. The material that we offer has a fixed Sure A value of 30. We're always looking for suggestions for improvements, and I'll take your suggestion, of course, into consideration, but we're always looking for feedback on our materials, the performance. But today, the Sure A 30 is a fixed value for those particular materials. Someone asked about the wax from the supports. Is it reusable and how does it load into the printer? So all of our material is fed through it's basically a plastic cartridge. That cartridge is loaded into the printer, and that's what feeds the material up to the print head where it's actually jetted and cured on the platform. The wax material is a waste. It's thrown away. It's not reusable or recyclable. It can be added back into the printer. But it is a non-toxic eco-friendly waste. You don't have to handle it in any special way. It's not considered hazardous at all, and it comes off really easy using our Easy Clean system. Someone asked if there are any metallic materials for printing. So not on this printer. This printer is not a metal printer. This prints plastics and elastomerics. We do have metal printers as part of our DMP or direct metal printing technology. So we do have metal printers, but we do not have metal printers or materials on the ProJet 2500. Someone asked about how fast is the steam post-processing against the traditional oven post-processing. So for those of you who may not be completely familiar with our different post-processing methods, I talked about one of them, which is fairly new, and that's the MJP Easy Clean system, which is a steam-based system. We also provide a finisher oven, which is a large industrial convection oven. It uses circulated air to melt the bulk wax and to remove the support material. When you compare both processes, the steam process can be up to 4 times faster than the traditional oven process. So it's ideal for people who are looking to produce parts, clean parts extremely quickly. It allows them to get in and get out of the post-processing very fast and get to their final part. There's a question about if the 2500 uses a print head like the 3600 series, or if it's an extruder. So it does use a print head. It uses an industrial print head that jets the material out. So it does not use any kind of extrusion process to print the part. Someone asked a question about the bearing that we showed in the presentation and wanted to know if it was one assembly or if it was assembled after printing. So that was printed as one part. That's a single part that had multiple bearing balls on the inside and then an outer sleeve and then an inner center core. The screw that was on the part was actually a secondary piece that printed separately and then we screwed it on. So it's basically a 2-part assembly, the main bearing and the screw that was at the top of the part. Someone asked about what is the base material that remains. So when you remove the support wax, the material that's left is your part. And that's actually whatever material that you have loaded into your printer at the time. So if it's the rigid black, you'll take all the support wax off and the black part is what you're actually going to utilize. That's going to be your prototype or your testing part. Both the Easy Clean system as well as our oven system utilize heat to remove about 95% of the wax. There's a secondary process where we actually soak the parts in a light soy-based oil for a few minutes. That allows all of the residual wax and any wax that might be hidden in crevices or internal cavities to be washed away. The third process is just washing the part in warm soapy water, which removes the oil. And if you remember some of the images that we showed of parts that had internal cavities, that was complete 100% support removal. And that's important for many, many applications because if you're going to be painting or plating or doing some other process or running fluids through the part, you want to make sure that you get all the wax off, all the oil off. Someone asked about what is the maximum temperature that the parts from the ProJet 2500 can withstand. So all 3 of the rigid materials have a fair, I would say, low to moderate heat performance profile versus some of our other printers in materials like M3X. When people talk about withstand, it kind of depends on the application. For example, if I'm printing a fairly robust and bulky part that's not under load, it can withstand extremely high temperatures. The materials themselves don't melt because they're thermoset plastics. They're not thermoplastics. So at high temperatures, and I'm talking like 230 degrees C or 450 degree F, they would flash burn. But, you know, if we're talking 100 degrees C, 150 degrees C, it really depends on the geometry itself and the part. If it's a very thin-walled housing or something very delicate, very elevated temperatures may cause that part not to perform as expected. Someone asked about the material being safe for food processing. So these materials are not certified, not FDA certified, or not certified for use in or around food products. Again, this is primarily a prototyping printer. We do have other printers that are suitable for medical applications, but as a family of materials, anything that's UV curable is typically not food safe. Our SLS, selective laser sintering technology, does have materials that are food safe and that are fully useful in food and medical applications. Someone asked to explain the importance of a shoreline, and I think they may have meant the shore A value. The importance is really determined by the application. There are some applications that require a specific shore value to basically approximate what a silicone final product might be or what a polyurethane final product might be. If they have an idea of what their final product might be and they know that that product needs to perform at a Sure A, let's say 40 hardness, with the 2500, again, that's a fixed Sure A value. With our 5500X, we can produce composite materials that have a range of Sure A values, from Sure A 30 all the way up to Sure A 80 or 90. Someone wanted to understand the comparison between the 2500 and the other printer models. So the 2500, from a price point, and I'll talk about price point, materials, and other things, from a price point is the most affordable entry-level professional printer within the MJP family. So it's priced at under $50,000. The ProJet 3600 is our flagship printer within the MJP family. It's got about 8 or 9 years under its belt. It's actually on its 4th generation printer model. And so it is, I would say, by far our most capable and versatile printer. That being primarily because of the phase change material, both in part and support material. So in terms of part quality, we're able to get very, very fine features, even finer than what we can do on some of our other MJP printers. Also, with the 3600, we have some advanced materials like the M3X, which is very suitable for injection molding applications. We have VisiJet M3 Crystal, which is Class 6 capable and suitable for a lot of medical applications. And we have the very tough and durable M3 Black, which is used in a number of different prototyping and functional testing applications. Our 5500X, I would say, is our most exciting printer. And then before I go on to the 5500X, the 3600 operates in 5 models. 2 of them are plastic, 2 of them are wax, so we can actually produce wax patterns for investment casting. And then we have a dental printer. So again, the 3600 ranging in price from $74,000 up to $98,000 is a very versatile printer that is a good solution for a lot of different applications. The ProJet 5500X is probably our most exciting printer because we can do multi-material printing. We can mix rigid and elastomeric and create composite materials. So there's a lot of variety in the types of applications and types of parts that the printer can produce. The 5500X is priced at $225,000. So that's kind of a layout and a general positioning of the three printers that we have within the MJP family.
And Derek, we'll take one last question before we wrap up.
I'll take a question about maintenance and usability of the printer. So this question was, what is the level of maintainability required involved with the 2500, specifically cleanings and hours between cleaning? General operation includes making sure that there's enough material that's being fed. The printer will send the user messages to let that user know that the material needs to be changed out. There are also three primary maintenance routines that are done, and these are done based on the number of print hours. The only thing that's required on a regular basis is making sure that your material is loaded, you have a clean platform for every build, and that your waste tray is empty. The printer itself will let you know when the regular maintenance is required, which is typically based, again, driven by the number of print hours. And one of those maintenance activities is a visual inspection. Again, it tells you when it's time. It's literally a 5 or 10 minute process. If there's any physical obstructions or junk in that area, you can clean it off with a lint-free cloth, and that's pretty much it. The other one is a waste trough that needs to be checked periodically. And again, the printer lets you know when to check that. The third item is the carbon filter that, again, typically only needs to be changed once or twice a year. But periodically, the printer will ask you to check it to make sure that it hasn't gotten too dirty. So those are the three main maintenance things. And everything else is just changing out the platform and making sure that your material is full. There's no calibration that's required on a regular basis. There's no print head cleaning that's required by the user on a regular basis. All of those things are automated, and the user basically just submits his builds, prints his builds, takes them off, cleans them, and is able to use his parts.
Great. Thank you, Derek. And thank you, everyone, for joining us and for all of your great questions. We're really excited to be able to share our information with you today. And as I mentioned earlier, any of your questions that you submitted that we couldn't get to, we will answer via email. Thank you again, and enjoy the rest of your morning, afternoon, or night, wherever you may be in the world. Thank you.